Right, in this video we're just going to have a look at the very basic properties of waves. We've got two types of waves here. We've got a transverse wave, which is that one, and a longitudinal one over here. So transverse one moves up and down, so it's perpendicular to the direction of travel, and this one it's actually parallel to the direction of travel. The way it vibrates is parallel to the direction of travel. So essentially it's moving like this one moves like this, but the whole wave's energy is transferred that way. And for this one it will be this way as well. I've just guessed, it could have been either way. So what we have here is, for both waves we can actually get the wavelength. So wavelength, we can measure it in a number of different ways. The easiest one I find is just going from peak to peak. So that there is one wavelength. Wavelength represented by a lambda. So how do we do that on this diagram? Well, on this one we've gone from the same position to the other same position, and we do exactly the same on this one. We go from this point, which is that, to this point over here. So that there, for me, is a wavelength. How do we get the amplitude? Well, amplitude is just basically you go from the zero line right up to the maximum sort of peak. So that there is my amplitude for this. Frequency, well, I can get the frequency because I can look at the time period for this wave. So I can look at how long it takes one wave to complete one cycle. So it goes from there all the way back there. So this here is 1t, and as we know, f is equal to 1 over t, so we can get the frequency. Another thing we can get here is peak to peak voltage from there to the bottom there. So that's used in electricity, and for this one we can get the time period as well if we had a scale. Thank you.